So we are going to cover this chapter, mechanics. All right, now, what are the things that is basically included in this particular unit? So we have the kinematics. The kinematics that is involving the motion in one dimension, motion in a straight line, motion in one dimension basically. That is including the straight line motion and the motion under gravity. Then we have the projectile motion. Okay, then after that we'll be learning about the forces. We'll be learning about under the forces we'll be learning about the Newton's laws. Okay, Newton's laws of motion. Yeah, we'll be covering the first part of momentum. I'm just naming it as the momentum 1. Okay, and then we'll be covering the free body diagram. And then we'll be covering the momentum part 2. Then next we have the work, power, energy. Okay, so in this order we are going to cover this entire chapter. Yeah. All right, so let's start with the very first one, that is the kinematics. Right, so that is the simplest one, in fact. Yeah, you should not find any kind of difficulty in that, but like still, like after doing the session, if you find any kind of problem while doing the numericals, you can definitely get back. Yeah.
Okay.
Right.
Yeah.
So the kinematics is basically talking about the motion. Yeah. Now the thing is, why are we learning this particular topic? What's the importance? What is the significance of knowing this particular chapter? So see, the thing is, there was a guy, a Ukrainian guy. You must have heard that, like, he launched a missile to hit the Malaysian airline a few years back. Heard about it?
Yeah.
Yeah.
I heard about
So
it.
yeah, so basically there is an airlines. Okay, like there was an aircraft, and that was actually going with a speed of 900 km per hour. Okay, at a good height of 11 kilometers, 33,000 feet. Okay, like if you know, like at what height the aircraft's actually flying, right? So this is at a very good height of 11 kilometers. Okay, so what this guy did, so what this guy did, like he launched a missile. He launched a missile to hit this aircraft. Okay, so he must have estimated at what angle it should be launched and with what speed it should be launched, isn't it?
Right. Yeah.
And he was able to hit this aircraft very precisely. So basically, this guy, he must have calculated this value. He must have calculated this value. He must have calculated this, and also the angle. Besides that, there are many other things which should be calculated, like the efficiency, mass of the fuel, the dimensions of the missile, everything. Okay. In short, to become a terrorist also you need to know mechanics. Okay.
Right.
Yeah. So besides that, like the people in ISRO and NASA, when they are launching any kind of rocket or the missile, they do all these things theoretically, first of all, on the paper with the programmers, right? And then they execute their plans, isn't it?
Right.
This is definitely a very important step. So like to understand all these things, you need to know mechanics. Okay. Besides that, to understand the mechanism of any machine and its efficiency, okay, and how it should be processed. So to understand all those things, obviously you need to know mechanics. Okay. So this is the basic significance of this particular chapter, and this is why we are learning this particular chapter. Besides that, you already know 2 more reasons, that it's in the syllabus and you need to score marks. Yeah. All right, so let's understand what is the state of motion or what is the state of rest. Okay, so here let's talk about the state of rest and state of motion. So how do we actually define these 2 states, state of rest or state of motion? See, the thing is, when I say that here, this object is at rest, okay, when I say that this phone is at rest, Is this the right
Yeah.
statement in the? Is this the right statement in physics when I say that this object is at rest?
Rest means that it's all the forces are in balance, so it's not moving. Or it can be moving, but it means that each has equal forces on each side.
See, the thing is, when I say that this is at rest, in physics, it's not a right statement. I must say that this is at rest with respect to what? With respect to me, with respect to you. Okay. Why? Because
Yeah.
with respect to us, it is not changing its position. With time, it is not changing its position. You're getting it? Yeah. So in that case, we can consider
Yeah.
that, like, since it is not changing its position with time with respect to us, that's why we are considering this to be at rest. But like, let's consider an observer who is on moon, let's say. So for moon, Earth is moving. For Earth, moon is moving, isn't it? Yeah.
Yeah.
So in that case, like, if the person who is on the moon, he's observing that object. Okay, he's observing my phone, so he'll feel that, like, this phone is moving. Why? Because Earth is moving. Okay, let me
Right.
give you, like, all these are like huge. I'm involving the huge thing. Okay, in the example, let me give you a very simple example. Here, I'm considering this car, and in this car, we have A and B sitting next to each other. Okay, and this car is going with a speed of, let's say, 50 kilometer per hour. Yeah, in this forward
Yeah.
direction. So now this is a constant. This is going with a constant speed. What A will feel that B is at rest. What B will feel that A is at rest. But let's consider,
Right.
and
Regard to the car.
yeah, let's consider another observer, C. Now C will feel that both A and B are moving. Okay, why is it so?
Yeah.
Because with respect to B, A is not changing its position, or with respect to A, B is not changing its position. But with respect to C, both A and B are changing their position. And that's why they are
Yeah.
considered to be in the state of motion for the observer C. Okay. So what is the state of rest when the observer, when object is not changing its position, not changing its position with respect to an observer. Okay. Then we consider it to be at rest. Okay. Whereas when it is changing the position, when the object changes its position, changes its position with time, with
Yeah.
respect to an observer. Okay. So in that case, we consider it to be in the state of motion. Yeah. All right. So this is kind of, you can say that this is basically the relative phenomenon. Yeah. This is
Yeah.
the relative phenomenon. Yeah. I can give you a brief explanation of how the motion can be different for different observer with a
Okay.
similar example. See, the thing is, what I'm considering here, I'm having here, this guy is on this cart, and this whole cart is going in the forward direction with a big speed, let's say 20 kilometer per hour. Okay. Yeah. Now this guy is throwing a ball in the upward direction. Okay. He's throwing a ball in the upward
Yeah.
direction. And when the ball comes back, okay, it will come back in his hand. Okay.
Yeah.
Let's say this is observer A. This is that observer only. So for A, for this observer A, what he will feel that the object has gone up and came down. So this is simply like motion under gravity. Motion
Yeah.
under
Without
gravity.
air resistance, right?
Yeah, without errors. Motion under gravity in a straight line, basically. So that's what he will feel. Yeah. But if I'm considering another observer who is actually observing this whole thing, the whole journey by the ball, what he will feel that the ball is actually going like this. This is the projectile motion. Okay. So you can
Yeah.
observe, so you can actually see that both A and B perceive the motion differently. You're getting
Yeah.
right?
Yeah.
Yeah. This
Yeah.
is
Yeah.
all because that the motion is the relative phenomenon. Now, with this basic mechanics, you will be able to understand the 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 general relativity or the special theory of relativity also. Okay, if later you try to actually like do a course like in those things. Okay, anyways, so can you tell me like which option your school would be doing?
I'm not sure yet. They haven't told us.
All right, so so going ahead, so like you understood what is the state of rest or the state of motion, right? Yeah. Now,
Yeah.
now let's understand different dimensions, different parameters to understand the motion. So let's understand those different parameters. So what are the different parameters to understand the motion? It starts with the
Internet is
distance.
unstable. I'll turn off my video.
Sorry.
The internet is unstable, so I'm turning off the
Yeah,
video.
yeah, that's fine. That's fine. So okay, distance. Okay, I have a kid, so like you may feel some kind of background noise. Yeah,
Yeah.
yeah, at home sometimes. So like sometimes he disturbs a lot. Okay, yeah.
Okay.
Anyways, yeah. So anyways, so we have the distance and displacement. We'll be learning about the speed and velocity, and also we'll be learning about the acceleration, deceleration here while doing the kinematics. All right, so let's understand the distance and the displacement. Okay, so I believe before going ahead, I believe you know about the scalars and vectors. Yeah.
Yeah.
Okay. Scalars are something which is having only the magnitude, and vectors are something which is having the magnitude and directions. Yeah. Okay. Scalars, they can be operated simple with the simple algebra arithmetics. Yeah. So, but like to operate the vectors, you need to know the geometry. Geometrical operation
Yeah.
is required. Yeah. Okay. So basically, what does this mean? That like if I'm having suppose a mass 20 kilogram, another mass let's say 30 kilogram. Okay. And if I'm stacking them like differently. Okay. Here, let's say this is 20, this is 30, and let's say this is 20, this is 30. In both the cases, the total mass is 50 kilogram only. Yeah.
Yeah.
But if you are applying the vectors, suppose 20 Newton is applied over here, 30 Newton is applied over here. Okay. And in another case, if suppose 30 Newton is applied over here and 20 Newton is applied over here. So here the resultant is 50 Newton definitely, but here the resultant is 10 Newton in this particular direction. Yeah.
Yeah.
So
Yeah.
this explains like how the geometry play important role in understanding, in operating the vectors basically. Yeah. Remember
Yes.
one thing, yeah, that if suppose this particular vector is representing 2 unit, let's say, okay, then in the same direction that another vector will be representing the 4 unit. The point is that like the vectors, their magnitude is given by the 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 arrow taken, length of the line that you have drawn with a
Okay.
specific scale, like suppose 2 unit representing 20 Newton, then 4 unit will represent the 40 Newton force, yeah, in that particular same direction. Yeah. So this is the
Yes.
distance. So this is the scalar and vector. Let's understand the distance and displacement. We'll be further understanding the operations on the vectors while doing the mechanics. Okay. Yeah. So let's
Okay.
understand first of all the distance and displacement. So I'm considering kind of track. Do you play Need for Speed or like any kind of racing games?
No, not really.
All right, no problem. So when you are going from A and suppose you are ultimately reaching B, let's say, okay, in this kind of circuit, okay. So so the racer, he started from point A and reached point B ultimately, let's say, yeah. So this is
Yeah.
the start point and this is the finish point. This is the finish point. Okay.
Yes.
So so the car is having a distance meter, yeah. So that is giving just a number. So distance is given by the distance meter, which is just a number, yeah. But what about the displacement? Displacement is a different thing. So how do you
Yeah.
define the distance over here? How do you define the distance in this given case? So
The
distance is,
distance.
yeah, you tell me.
The distance is the how far, like the it's basically the length of the route, and the
Yeah,
displacement is
exactly.
the shortest distance between A and B.
So distance is basically the length of the path traced. I can say that, yeah. So
Yeah.
distance is the length of the path traced, but the displacement is you said shortest distance. Do you mean to say that like vector is the shortest scalar?
And I
No,
meant to say that the basically displacement is how much you've moved from the
no. See,
initial.
no, that's a wrong definition. That's saying it's shortest distance. So it is basically the length of a straight line from initial to
Okay.
the final position. Okay, so it
Okay.
is. It should be defined this way, that it is the length of a straight line, from initial to final position. Yeah. So
Yeah.
basically, you're going from point A to point B. So that is the straight line. Okay. And the
Yeah.
length is the magnitude. And when you're saying from initial to final, you are showing the direction also. So it is having magnitude and the direction. So that's why we call it
Yeah.
vector. And this is having only
Okay.
the magnitude. So this is a scalar. Yeah. You're
So
getting it, right?
hypothetically, if the this is on a hill, right? Like the A and B is on a hill,
Yeah.
the displacement would still be that line, but hypothetically it could not be the shortest route because maybe there's a it's like you have to cross the mountain, so it take longer.
Yeah, exactly. See, the thing is, when I'm saying shortest distance, so it is uh, not aligned with the concepts of the physics, because you are saying that displacement is a vector and then you are equating it to the shortest scalar. Okay, so it's better to use the word length of a straight line, that is
Yeah.
starting from initial to the final position when you're defining it. But just for doing the questions, yeah, what the definition that you gave was correct. Okay, yeah, just for doing
Yeah.
the questions, not to define it with the concepts of the physics. Yeah. Okay, this has great. This has got like this whole idea, distance and displacement has got great significance. Where is that kind of significance? Where do you observe such significance? So, do you use the Google Map
Yeah. Yeah. Sometimes.
sometimes? Yeah. Okay, so go on Google Map and just I mean, like you take the phone, and in the phone go in the app Google Map and follow the steps that I'm saying. Just follow it like
Okay.
step by step. Don't go ahead before me saying anything.
Okay.
Okay. Yeah. So open the
Okay.
app. Open the Google Map app.
I have it on the laptop. Is that
No, no,
okay?
no, 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 no. Please open it on in the phone, please. You have the phone?
Okay.
Yeah.
Yeah, I got it now. I'm opening it.
Okay.
Yeah, open.
Opened. Yeah. All right. Then
Yeah.
in the on the top you will see there is a bar. Search bar. Yeah.
Yeah. Yeah.
On the click on the search bar and then type like your school must be nearby. Is it?
Yeah.
How far is your school, by the way?
I think around 5 kilometers. I'll see.
No, don't. So just type your school's name. That's it. Just type your school's name.
Yeah, I typed it. Yeah.
Okay. Now, once you typed it, you will observe some options. Like there are many options which you get. And on the left side of those options, the distance is also mentioned.
I don't have the location enabled, so it doesn't say the distance. But if I put directions to show the distance.
Okay. The point is like if I'm showing you my screen, let's say, wait a second.
Yeah.
Okay. So when I show you my screen, will you be able to see it?
Yeah.
Can you see my screen?
Yeah, I see it. I see it.
So on the left hand side, you can see the distance also given.
Yeah.
Yeah. What distance do you see over here?
5.6. Oh, for you, 28 kilometers.
28 kilometers. Now on that same thing, Daisy Garden, I'm clicking. Okay. I clicked it. How much distance did you see earlier?
28.
Okay. Now, when I click on the navigation, what distance you're seeing?
38 kilometers.
Perfect. All right. Now, the point is when when I started from point A, I'm sitting at point A and I was searching for point B basically. Okay. Here is the
Yeah.
satellite which is using which the this GPS is working actually. So this is a satellite, yeah, using which the GPS is working. So it takes the coordinates of point A and point B and gives me the straight line, the length of the straight line
Yes.
from A to B, which was 28 kilometer. Okay. But when I clicked on the navigation, it is giving me the route. It is giving me the route to reach this point B. And this is coming out to be 38 kilometer. So this is the distance. And this one is the displacement. Okay. If you
Yeah.
understand this thing, you'll be able to understand the programming of the Google map also. Okay.
Yeah. Yeah. Makes
Yeah.
sense.
Yeah. So this
Because
is
it's just showing you how far that city is away from your current place versus how far you have to drive to get there, for example.
yes. So the distance is the length of the path that you trace, and the displacement is the length of the straight line from initial to the final position. You're getting it, right? Yeah.
Yes. Yeah.
All right. Let's go ahead. So basically, we understand what is the distance and what is the displacement. Yeah. So now I'll be giving you a checkpoint. So with
Yeah.
every questions, with every concept, I'll be giving you the checkpoints. Yeah. So let's consider a circle. All right. So here, let's consider a circle. Okay. And this circle is of radius equals to 7 meters, let's say. Okay.
Okay.
And a uh, this x and y, they are basically along the diameters and they're perpendicular to each other. Okay. And this
Yeah.
is the center. Yeah. Now you start from point A and then you go to B, then C, then D, and then you come back to A. Okay.
Yeah.
Now, when you are traveling from A and then coming back to A anti-clockwise, okay, so you must
Mm-hmm.
be covering some kind of distance and the displacement. Okay, when
Okay.
you cover the distance like A to B or A to C, A to D, A to A, you have to calculate what distance it covers and what displacement it covers for these individual part of the journey. Like A to B, A to
Okay.
C, A to D, A to A. What is, remember, R is equal to 7 meters and take pi as 22 by 7 and tell me the answer quickly.
Okay. So if we do, okay, thank you for that. 22 by 7. I was just going to. So then
Perfect.
it's 1/4 times diameter is 14.
Diameter.
Yeah. If you need a circumference, you
Circumference, yeah. So let's say circumference is 44. We got circumference to be 44. Circumference is 2 pi r or pi d. Yeah. So that is coming
yeah,
out to 44 meters. So what do you think the distance would be?
the distance from A to B,
Yeah.
11 meters.
Yes. So you know that this will be 22 meters, this will be 33 meters, and this will be 44 meters. Yeah. How about the
Yeah.
displacement?
So the displacement, 7, a bit of Pythagoras, I guess.
Perfect. So this is 7 root 2. This is, how about A to C?
A to C is just a straight line of 14
Very
meters.
good. Shabash. Very good. And this will be 7 root 2 meters. And again, this will be 0 meters. You understand that, right?
Yeah, 0 meters.
Perfect. All right. So now to understand this thing further, we need to have the graph analysis of the distance versus time. Okay.
Yeah.
So, so I'm gonna take the graph analysis. Okay. So here in this graph, here this is all these are like D. So there are basically I'm actually showing 4 graphs. One graph
Okay.
1, graph 2. Here this is the third graph, and here this one is the fourth graph. Okay. So
Okay.
this is with the time. Okay. All these are the distance versus time. All these are the
Yes.
distance versus time. This is, let's say, for 1 second. This is for 2 seconds. This is 3 seconds. This is the 4 seconds. Okay. So and the so what do you observe that this is going in a straight line. So basically,
Yeah.
it is maintaining the at the same position with respect to time. So this is
Yeah.
basically at rest. You understand that,
Yeah.
right?
Yeah.
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 How about this one? Like here in the first second, it covered this much distance. Yeah,
Yeah.
this much distance. The coordinate for this is like over here. In the next second, it covered this distance. In the next
The
second, it
same
covered
amount.
this. So same amount of distance being covered, right? So over
Yeah.
here, so same distance in same interval of time. Same distance
Yeah.
in same interval of time. That's what you are observing. Interval of time. Okay. You observe a straight line which has the constant gradient basically. Okay.
Yeah. And the gradient is the.
Yeah, and since it is covering the same distance in same interval of time, that means it is having the same speed. Yeah, so the
Yeah. With
constant
no
speed.
acceleration.
Yes. When you observe this graph, so when you observe this graph, you observe that like in first second it covered very little distance. In the next second it
Yeah.
covered slightly greater distance. In the next second it covered further greater distance. In the next second it covered further greater distance. So basically
Okay.
increasing distance in successive interval of time, increasing
Yeah.
distance in successive intervals of
So
time. Yeah,
it's accelerating.
yeah, and it is having the increasing gradient. Do you understand
Yeah.
that it is having the increasing gradient, right? Yeah,
Yeah.
and here you just said that it is having the increasing speed. Increasing speed. We call such thing an accelerated motion, right?
Yeah.
Accelerated motion. So, and over here in this particular case, it covered really good distance in the first second, but like the distance is gradually decreasing. And
Yeah.
also the gradient is also decreasing. So here you say that it is having the decreasing speed
Or
and
decelerating.
gradient. Yeah.
Yeah.
Yeah. So then you are saying that this is the decelerated motion, deceleration. In all these cases, when gradient is constant, speed is constant. When gradient is increasing, speed is increasing. When gradient is decreasing, speed is decreasing. What we can
Yeah.
what we can conclude that in the distance versus time, the gradient gives you the
Is speed.
speed. Yeah. Okay. So gradient is giving you the speed. Now, have you done calculus?
Yeah.
Yeah. So in calculus, the speed is considered with the first order derivative of the distance, basically. Okay. So
Yeah.
if the distance is the function of x, then the speed is the first order derivative of x of the
Yeah.
function. You're getting it right? Yeah. Do you have
Yes.
any problem in understanding this part?
No.
Perfect. Or we can say this is the derivative of fx. Yeah. Anyways. All right. So this is a basic analysis of the distance versus time graph. Now let's consider. So here you got introduced to the term speed or the velocity. Velocity is basically when you are considering the rate of change in displacement. Okay, because velocity is considered with a vector. So you're supposed to know about the concept of average speed. Now, what is average speed?
The speed at each interval divided by the number of intervals.
Okay, is it the mathematical mean of different speeds taken? Mathematical mean of different speeds? Is it
Yeah.
wrong? It's not.
Oh.
Okay. Like suppose if I'm going from point A to B, and suppose there are some intervals like C and D. So from A to C, you were constantly at 20 kilometer per hour, let's say. Okay, and you went for like 3 hours, let's say. From C to D,
Okay.
you were constantly covering this distance with let's say 30 kilometer per hour for 5 hours, let's say. And from D to B, you actually covered it with 10 kilometer per hour, 10 kilometer per hour for 10 hours, let's say. Yeah. So
Yeah.
So like when you're saying that it is the mathematical mean, so you will simply take 20 plus 30 plus 10 divided by 3. Yeah,
Yeah.
average speed. If I'm considering the mathematical mean, it is 20 plus 30 plus 10 divided by 3. Yeah, but it's not true. Why is it not true? Because when you learn stats, and there if you learn the concept of average, you take the data which are in the identical conditions. Okay, then you can
Yeah.
take the mean of by adding all the data and then dividing by the number of data that you have. Yeah, but here the
Okay.
conditions are not identical for all the cases. The conditions are different. Here it's for 3 hours, this is for 5 hours, this is for 10 hours. Is different distance. The distance over here is 60 kilometers. The distance over here is 150 kilometers. Okay, and the distance over here is 100 kilometers. Okay, so
Yeah.
the conditions are different. So here, how do we define the average speed? Average speed is defined as the total distance over total time. What is the total distance? 60 plus 150 plus 100. What is that? 210 plus 100, that is 310. Divided by total time taken. Total time is 358, 10, 18. So 310 over 18. What is that coming out to be?
It gives 17.222.
17.22, right? And when you
Yeah.
do this, this is coming out to be 20, which is not correct. You're getting it. So this is the right
Yeah. Yeah.
answer. So the average speed is basically the total distance over total time. Okay. Yeah.
Okay.
All right. So here I'm giving a question. Try doing that question on the average speed. So you are suppose starting from point A and you go to point B. This is a straight line motion. Straight line motion. Okay. Yeah. So starting from point A, you're going towards point B. Okay. While going, you're going with 50 kilometer per hour. And while coming back, you're following the same route, same straight line, and you're coming back with 90 kilometer per hour. Okay. So
Okay.
what will be the average speed for this entire journey going from A to B to A for the entire
So,
journey? What will be the average
so
speed?
how long did it take?
Nothing is given.
Okay.
Yeah. So try
Uh,
doing this. Okay. So when you consider the distance from A to B to be X. Okay. Yeah.
okay.
So what do you think? So let's consider A to B and B to A separately. So the distance over here is X. Yeah.
Yeah.
What is B to A distance?
The same.
Same. Yeah. The speed over here is 50 kilometer per hour. Over here it is 90 kilometer per hour. What's the time
Yeah.
taken in that case? Over here,
Um, the time is then multiply both sides by 1 over x, and then you get x over 50.
yeah, and this will be X over 90. Yeah.
Yeah.
Yeah. So what is the total distance? Total distance will be equals to 2x. And what is the total time taken? X over 50 plus X over 90.
X plus, yeah.
Yeah. So this is the total time taken. That would be X over 50 plus X over 90. You can take X common. 1 over 50 plus 1 over 90. You can write that as X common. And over here, 90 plus 50, that is 140 over 50 into 90. Something like that. Yeah. Isn't it?
Yeah.
So what is the average speed? Average speed is total distance over total time. Total distance is 2x. That divided by total time taken is x into 140 divided by 50 into 90. This x cancelled. What you get
Yes.
ultimately is 2 into 50 into 90 divided by 140. Yeah, so this is 100 times 9, 900 divided by 14.
Yeah.
So whatever you are getting over here. Yeah. Okay. So this will be 14 6 84,
64.3.
64.3 kilometer per hour. So this is how you do it. So did you understand this whole thing?
Yeah, you have to like rearrange it.
Yeah. So you have to get the total distance and total time. Anyways, this is not at all difficult. Okay. But it was kind of non-familiar, unfamiliar to you, right? Yeah.
Yeah.
No problem. Now let's understand, since we got introduced to the term speed. So now let's understand the speed versus time graph. Okay. Okay. So over here, over here, this is graph 1, this is graph 2, graph 3, graph 4. And in all these cases, this is V versus T, by the way, this time. Yeah, this is V versus T. Okay. So, and this is 1 second, this is 2 seconds, this is 3 seconds, 4 seconds. Yes, this is basically having the constant speed. Yeah, this
Yeah.
says that it is going with the constant speed. Let's say constant speed is 30 kilometer per hour. Okay, and sorry, 30 meter per second. Let's say. So this is, let's say, 30 meter per second. Yeah.
Yeah.
So in 4 seconds, what distance it will be covering?
120
Yeah.
meters.
So in 4 seconds, it can cover the distance equals to 120 meters, right? That can be in fact determined with this particular area also. Okay, this
Yeah.
area is actually equal to 120 meter. Yeah.
Yeah.
Okay.
So the distance is
Yes, distance can
so
be obtained from the area
area.
under speed time graph, right? Yeah.
Yeah.
Okay. Now, when I'm considering this particular graph, so here in this graph, what do you observe is it is changing its speed at constant rate. Okay. Now, the rate of change in the velocity is defined as the acceleration. But since it is the motion in straight line, so even the speed can be considered. Okay. So the acceleration is basically obtained by the gradient, by checking how the magnitude of the velocity is actually varying. So acceleration is basically the rate of change in velocity, rate of change in velocity actually. Okay.
Okay.
And here it is given by the gradient of speed time graph, or better I should say velocity time graph. Okay.
Yeah.
Yeah. Now this one is saying that this is having the increasing acceleration. This one is having the increasing acceleration because it is having the increasing gradient. Okay.
Yeah.
This one is having the decreasing acceleration. This one is having the decreasing acceleration because it is showing the decreasing gradient. Okay. What do you think? If I'm saying this is a positive acceleration, what do you think about this one? Is this a positive acceleration?
Negative.
Wrong. This is also.
Oh no, no, no. Actually, no.
This is also positive.
It's also
The point
positive because
is,
it's not going in the
going
opposite
negative.
direction. It's just
Yes.
decreasing its value.
Yes. When I'm drawing, suppose here, velocity time graph, if I'm drawing something like this, here it is having the negative acceleration. It is having the negative acceleration. You're getting right?
Yeah, yeah.
All right. So now we know one thing, that the acceleration can be obtained with the velocity versus time graph by calculating the gradient. Okay. So
Yeah.
let's understand this thing properly. So we have I'm taking speed versus time, okay, because we are considering the straight line motion. But like later, I'll be generalizing the whole thing. Okay. So let's consider the speed time graph over here. So we have the object changing its speed from u to v, let's say,
Okay. Yeah.
in time t over here. Yeah. So the gradient over here, you can see the gradient which gives you the acceleration. That is nothing but the rise over run. Yeah. So
Yeah.
acceleration, that a is equals to v minus u over the time taken. Yeah. So with this you
Yeah.
get v is equals to u plus at. Now this is the first kinematical equation. Yeah.
Yeah.
First equation. of the kinematics. Other thing that we learned, that the area under the graph that gives you the area under the graph gives you the distance, right? So what I'll do, I'll basically divide it into two parts, two areas. So we
Okay.
are having let's say this upper one and the lower one. These two areas I'm considering. Yeah. So here is another area. Yeah. So basically, when I actually calculate the entire area, we'll be getting this is A1. Let's say this is A2. We'll be getting the distance, right? So the distance displacement impact is given as the sum of these two areas. Now, what is A1 over here? A1 is just the rectangle, isn't it?
Yeah.
What
So
is the
it's
area of
just
rectangle? What is the area of rectangle?
base times height. The base is t and the height is u, so ut.
UT. Plus, what is this A2? It's a triangle, right? So that is half
Yeah.
into base. Base is T into height. What is height, by the way?
V minus u.
V minus U. But what is V minus U from this equation?
Acceleration is displacement over time, right?
V minus U, making the V minus U the subject of formula 80. Yeah. So V minus U is
Yeah.
80. So I can simply write 80, isn't it? So this becomes
Yes.
UT plus half 80 squared.
At squared.
Ooh, you're getting it, right? Yeah.
Yeah, yeah.
So
This the suvat equations.
yeah, so this is the second kinematic equation. This is the second equation. There is one subordinate equation that is not like considered with the third equation. I'm giving you a subordinate equation. I can consider this whole thing, like I can get the area by considering this entire trapezium, like this entire trapezium, in fact. What is the area of
Yeah.
trapezium? Half into sum of parallel sides. Parallel sides are this and this whole thing. Yeah, so that
Yeah.
is u plus v into the distance between those two parallel sides, that is t over here, correct?
Yeah.
So even this can be written as, I can write v plus u over 2 into t. That also has the distance formula. You're getting it, right?
Yeah. Yeah.
All
Yeah.
right. Okay, now uh, if I'm considering the same equation, s is equals to v plus u over 2, and instead of t, what I'm doing, I'm writing v minus u over a. Then are you confused with this?
Slightly. Well, v
I'm just
minus
taking,
u.
instead of t, I'm writing v minus u by a. From this first
Okay.
equation, make t the subject of formula.
Yeah.
That becomes v minus u by a.
Yeah.
So instead of this t, I've written v minus u by a. Now what
Yeah.
is v plus u into v minus u? V square minus u square.
V square minus u square. Yeah.
And then at the bottom you have
2a.
2a, and this is s. So therefore, we can say v square minus u square equals to 2as, and then therefore we can say v square equals to u square plus 2as. So we got this
Yes.
another equation. This is the third equation. Yeah. See, the thing is, this is basically the derivation of the all the kinematic equation. In fact, you don't have
Yeah.
to mug up anything. Okay, you understand everything from the graph, from basic analysis of the graph. Okay, and just with the basic definitions. Yeah. So remember one thing: whenever you are having the questions on these things, so you already know that like you have to use the suvat equations. So you know
Yeah.
that you know the letters S U V A T. So
Yeah.
it's suppose out of all these, when you write the set of known and unknown, when you write the set of known and unknown, and that set, if it is coming out to be S, if that set is coming out to be V U A T, we use the formula V is equal to U plus A T. If
Yeah.
that set is coming out to be S U A T, we use the formula S is equal to U T plus half A T square. Okay. If it is VUST, then we use the formula S is equals to U plus V over 2 into T. And if we have VUAS, then we use V square equals to U square plus 2AS. Okay.
Yeah.
So whenever you get any of these questions, try to make the set of known and unknown. Okay. What you are given and what is asked. If that
Yeah.
set is VUAT, so you know which formula to be used. Yeah. Okay.
Yes.
I'm giving you a few questions. Try doing that question.
Right.
You're given the initial speed that is 10 meter per second. Acceleration is 2 meter per second square. So calculate first thing distance in 5 seconds. Second thing distance in fifth second.
Okay.
Speed at t equals to 5 second. Yeah, this is first question. Second question.
Okay.
Yeah, second question. You're starting from point A. Understand all these questions first, and you're going to B. Okay. If suppose
Yeah.
this entire distance is x meters, let's say.
Yeah.
Yeah. You started with A with rest 0 meter per second, and you are accelerating at the constant rate of A meter per second square, and you attained the speed of 40 meter per second after covering a distance of x meters. Okay. Yeah.
Yeah.
So what do you think when you're at this point P, which is actually at 3x by 4 meter distance from the start? What do you
Yeah.
think the speed would be at this particular point? Okay, if the
Yeah.
acceleration is A only. This is the second question. You understood the question, right?
Yeah.
All right. Here is another one. This which book do you refer? Sokos?
I refer to the D. Homer Pawan Jones book.
Okay, all right, yeah. So basically, there are some good questions. You must try all those questions. Besides that, like you can go on my website to find the worksheets and the past papers with the mark schemes also. Okay,
Okay.
yeah, yeah. All right. So over here, I'm giving another question. You're starting from point A, going to B, C, and then you reach D. So this is B, this is C, this is D. Okay. Now they are not equal distance, by the way, but this is definitely the straight line motion. Yeah, everything
Okay.
is straight line motion. Yeah, you started with 0 meter per second. You attained the speed of 30 meter per second by accelerating at the rate of x meter per second square. Okay. Then while going from B to C, you covered this distance in t seconds without any acceleration. Here a is equal to 0. So that means what should be the speed at C? Greater than 30, less than 30, equal to 30.
The speed should be same as 30.
Definitely. It is still 30 meter per second. And then in the last part of this journey, you are decelerating at negative 3x meter per second square. Okay. And you come down to rest. Okay. You come down to 0 meter per second basically. Now this entire length is 6 kilometers. And the time taken entirely is 5 minutes. Okay. Then find the value of x and t. This is a challenging one. Yeah.
Okay.
So you have these 3 questions and you have 5 minutes. Start.
Okay. One and the third one.
Okay. Second part of the number 1. See. So distance in the 5th second. See, suppose you are starting from here, and then in 5 seconds you reached here.
Yeah.
So this distance is the distance covered in 5 seconds. But when I'm saying fifth second, that means I actually mean this distance.
Okay.
This is the 5th second.
I see.
So what do you have to do? You have to use the formula S is equal to ut plus half at square, or t equals to 5. and then for t equals to
Subtract t
4,
is equal to 4.
yeah, exactly. So that can be done. You can do it, right?
Yeah.
Did you get the value for speed at point P in the second question?
I think it's 30 meters per second.
30 meter per second. I'm not sure. Like even I have to do that. Okay, so see when I'm considering A to B. So for A to B, U is 0, V is 40, A
Yeah.
is something, and S is equals to X. So which formula should I
Yeah.
use? By seeing U, V, A, S, which formula should I use?
UVAS, then the one of them without T. One moment, the
V
formula is
square
missing.
equals to U square plus 2AS. Yeah?
Yeah.
So, so what I'll do, I'll get the value of A in terms of VUX. So this is 1600 divided by 2x. So A will be equals to 800 over x. Do you agree?
Where is this coming from? The V squared is 1600. Yes, the initial speed is 0. So it's 1600 is equal to 2AX.
So this is 1600 minus 0 divided by 2x. So this will be 800 over x. You get it?
Okay. Yeah. Yeah.
Yeah. So now from A to P, we have U equals to 0. We want V. We are given A as 800 over x, and we are given S as what we are given S as 3x over 4.
Yeah.
So S over here is 3x over 4. So again, the same equation we'll be using V square equals to U square plus 2s. So we will be getting V square equals to U square. U is 0.
Yeah.
And that 2 into A is 800 over
1600 over X.
800 over x.
Yeah. Times
3x
3x
by
over
4. Yeah. So 2 2s are 2 400s are. So x cancelled. So what we are getting over here is 400 3s are. So that is 1200. So V is equals to under root 1200. So what is that coming out to be? 33.33, I guess, right? Yeah.
Yeah.
Okay. Yeah. So I think you got the same answer, right? Yeah.
I got kind of close.
Okay, close to that. Yeah, no problem. And this one is the homework. I want you to try this one. Okay.
Okay.
I'm just giving you the hint that you have to use the for this you have to use the graph. Okay. I'm just giving you the hint. Okay. Yeah.
Yeah.
Sorry.